Okay, continuing with the explanation about topics on ROS 2, we will now do something related to the same thing that we did before about publishing and subscribing, but now in Python. And for that, we will have to create our package of Python just to keep these things ordered, because as you saw, we will here or C++ publisher subscriber. So let's move and create our package related to Python about the publisher and subscriber. ROS2 package create build type amend now is Python, and the license is Apache 2.0, and the name of the package will be PyPubSub. Inside the source folder. Okay, there is created. Let's confirm it. Okay, there is a package called PyPubSub, and inside the PyPubSub has this tree. Okay, for creating our publisher, let's move to the PyPubSub folder, and here we will put our file that is on the ROS repository to explain the PubSub. Okay, the file is pretty simple. There are not much lines of code here. You see that writing something in Python is very similar and also very basic related to how much lines of code it will take comparing with C++, but I prefer compiled programs that use C++ and not interpreted like Python. But for testing purposes, Python is very good. Now, let's understand here. We will import RCLPy and also the node. Remember that for this demo, we are using standard messages and sending a string over the network. And now comes the class that will be the minimal publisher. Okay, inside the class there is, let's say, a constructor and the callback. So for the constructor, we will then initialize the node as minimal publisher, and we will call or create the publisher as a type of message string over the topic name topic, and the queue is 10. We specify a time period of 0.5 seconds, and this we will create now a timer in over 0.5 seconds, 500 milliseconds, and we will explicitly I don't know how to say it, use a callback function that is defined inside the class. We will use an instantiation of the message and put over the data the hello, the message that we want to send over ROS, and finally we'll publish the message, because remember we put a publisher over here. We are using this publisher that is here to publish the message that we specify here, and also we log the message over the output stream to see what is happening, and the counter will increment by 1 to the next time, the other time that the timer will expire. It will send 2, 3, 4, and so on. And for the main function, here is the main function here. We will call the publisher and spin over this function, this node, and that's all. Now let's try to configure the parts of the package that are related to the execution of this code. Let's see. We can configure the package.xml, gedit. Okay, here what we can do is to modify the execution dependencies. For example, exec depend of rcl.py depend exec depend, and also the execution depends on standard messages exec depend, and that's all. Remember, these parameters are optional. If you want to modify it to keep these things up to date, it's up to you, but you don't need it to execute the code. You only, for example, for the execution dependency, you put it here. You can or cannot do, but it's a common practice to put everything. And now the next thing in Python that I think is not done over it, but we have to do it right now. We have to check over the setups. Usually the setup.config is built automatically, so you don't need to put it nothing to keep it work. And for the setup.py, you have to specify, for example, the entry points here. Where are? Okay, here, the entry points. And for the entry point, let's entry points. Let's move to the source folder. My pipe pops up. Okay, inside pipe pops up, there is a file named publisher member function.py. So usually you can put any kind of name here, but it's a common standard to put the same name of the function that you are calling. In this case, I will not put this. I will put publisher, and from Python pops up. I think this is this file, and we'll call the main function. Okay, that's everything that you need to modify here. Let's try to see if it is working, compiling the sources of the folder using colcon. Package select. Pipe pops up. Okay, where's 0? I think it's over the file that we specify the entry point. Let's move to C. Okay, I found the problem. The problem was here. I think this is everything. Sorry. So we will be lagging. And that's okay. Now, remember, you have to source everything. And now try to launch the node ROS to run the node. Py pops up. Let's see, there is something called publisher, and here is our topic, echo topic. Okay, there is the publisher, and now we are looking at the published data over here using ROS topic echo. Now we will stop it and try to write the other part of the code that is over the pi pops up. Here we will download the subscriber. And now gedit subscriber. Okay, now the subscriber is much more simpler than the publisher. Everything's remain the same here, but the main difference is in the subscriber. We subscribe this message over this topic and get a callback. When we receive something here, we will trigger the callback. And in the callback, in this case, we are just only receiving the message and printing the data that we hear over the network, and that's all. So what we need to modify, remember, we try to set the package.xml. We did it previously. We did not need to set it anymore. And now we probably need to modify this stop.py. Inside, we now have a subscriber over pipeup subfolder, subscriber, I think. Let me validate it. Source pipeup sub. Subscriber member function. Subscriber pipeup sub subscriber member function. We need here a comma and doxal. We will save it. Again, we will compile it using Colcon. We will launch the listener here to run by pops up listener subscriber, I think is okay, subscriber, and here just to run by pops up publisher. And now is working the same example here over ROS related to C++. We did the same thing using Python. Obviously, as I told you, you can have several subscribers over the network. Let's move and try to execute the C++ one. ROS to run C++ pops up. Okay, source ROS to run C++ pops up. Subscribe. And if we open the RQT graph, and see on nodes and topics. Okay, We didn't see everything probably because I put the same name of the node and we are publishing to the node. So it's a mistake of mine. Let's modify it just for fun. Let's modify here. Mm. CD source in pipe pops up. ls cd pipe pops up. Gedit subscriber function. A subscriber Python to differentiate. Con. Okay, source install. So, and now ROS to run pipe up subscriber. Subscriber pi. No. There are two subscribers. One is the subscribers over C++, and this is the one of Python. So I demonstrate here that you can seamlessly communicate between nodes and topics, and you can also have several nodes communicating with the same topic, and that's all. Everything about publishers and subscribers. Okay, thank you.